Hi everyone, welcome back to another video. So in this video we'll now finally be moving on to using the motors and learning how to drive the Asuro forward, backwards, etc. So there are two functions that we'll be using with the motors. So let's go back to our PDF. So we'll continue on from page 60, which we just finished this pole switch code here in the last video, right? So moving on now, the next piece of code that you've got is on page 61. And on this bit of code here, you've got a nice large chunky bit of code. Before we go through this, I want to explain it using more simpler codes beforehand, because this, as you can see, is quite a mouthful of code. So let's take our last piece of code and let's just clear it all out. Get rid of all of that, right? And then what we're going to do in this video is we're going to do an introduction to motors, right? And we're going to use two functions. Function one is the motor direct, dir, motor direct stands for, and the other function is motor speed. So what we're going to do with this program is we're going to drive the Asuro forward, right? And that's it. Okay. So what do we need to put? Obviously include, right, Asuro.h. Oh, int main, right? Then we're going to have a return 0 at the bottom. So this should always just be your standard. This is obviously your standard template whenever you're writing C code. So you should be used to writing this all by now. The only other thing to put here is just put void. You don't have to put necessarily. You don't necessarily have to put void, but I like to do it. Okay. So first things first is obviously we want to initialize the microcontroller. Hopefully you guys are familiar with doing that now. And then what we want to do is let's do a while loop, while one, right? And then we're going to put our code in here. Cool. So let's first turn the status LED green, right, which we've done many times before. And then now the two functions we're going to be using is motor right, motor direction it stands for, and motor speed. Both these two functions here, they both take two parameters. So you can look at it as they take an X and a Y. Take an X and a Y. So what you want to do is you want to go through and read page 67. And you want to read for the motor speed, you want to read page 68. So let's go to those pages now. Cool. So on page 67 at the bottom, it's got void motor direction, and then it tells you that it takes two parameters. The parameters are the unsigned character left direction and unsigned character right direction. That's basically a big way of saying that it's going to take two parameters that you need to put into it. So it tells you here, this function controls the direction of both engines and should be called before calling speed controls. This is an important point. Before you adjust the motor speed, you should call the direction, right? The call motor direction function before motor speed. Keep that in mind. So valid parameters are FWD, which stands for forward, RWD, which stands for backwards, brake, which stands for brake or sudden stop by short circuiting the motors in a transistor bridge, and free, which is freewheeling. So these are the parameters that you can put into this function here. So we're gonna put forward. Then now on page 68, we'll take a look at motor speed one. So this function controls the motor speed for both engines. Maximum speed is 255. The motor will start rotating at a value of around 60, meaning that less than 60, the motor is not even going to move, right? Depending on mechanical conditions. I find that for mine, usually less than like 80, it won't move. The parameter value in fact controls motor power, and the rotational speed also depends on other factors like friction or inclination in slopes. So the left motor is to move at a maximum speed, the right motor not at all. The direction of movement has previously been defined by direction. Cool. So you can set anywhere from 0 speed up to 255. So you put two parameters here, you put two numbers, do that for example, and then that motor speed will be set at 0. 255 is the maximum we could set it at. So that'll be motors full speed ahead. I'm going to set it at about halfway. One more, 150. Cool. So you can use any value from 60 to 255 to move. Use 0 for braking. Right? Cool. So now this program is fairly straightforward. What we're asking the Asuro to do is we're initializing the microcontrollers. We've got the microcontroller, sorry. We've got a while loop. We're turning the LED green. We're setting the motor direction towards forward, and then we're saying go forward at speed 150. All fairly straightforward, right? So what you should do is take this program, chuck in some of these parameters, RWD, brake, free, see what happens. Try the speed, set the speed to 0, set the speed to 55, 60, 90, 255. Flash it to your 0 and see what happens. Give it a go. The way that you're going to learn this, trust me, is by giving it a go. You're not going to learn much by just watching a video. Give it a go. Write the code yourself. Don't copy and paste and flash it to the 0. Bearing that in mind, all this code is being stored on GitHub, so you can always go onto my GitHub, which is here, asuro.public, and you'll be able to download all this code as well. Cool. Okay. So in the next one, we'll be improving on this code. What we'll do is we'll use some for loops in addition to what we've got here to get the motors to drive forward for a certain amount of time, as opposed to currently, which this program's doing, which is just driving the Asuro forward forever until it runs out of battery. Cool. Okay. I'll see you guys in the next one. Peace.